lesson 1 for 8.2, the quadratic formula. And in this lesson, I'm going to show you what the quadratic formula is and how we substitute into it so that allows us to solve for x when we deal with quadratic equations. In lesson 1, you were working with what's called complete the square. You were given a quadratic equation like this that couldn't be factored, and then we did what we called completed the square. We moved the third term to the right side of the equation. Then you took that idea of taking this middle term here and dividing by 2, and then you squared it, and that would then tell you what to add to both sides of the equation, and in this case it's 4. At that point you factored the perfect square trinomial into, in this case, x plus 2 squared, and we added 6 plus 4 and got 10. And then we did the square root of both sides, so that x plus 2 equaled plus or minus the square root of 10. Then subtract that 2 from both sides, and we'd have our final answer of negative 2 plus or minus the square root of 10. Worked pretty well. Well, these work very well for a problem like this one for 2 reasons. Complete the square works very well when the first term is just good old-fashioned plain x squared. It also works very well when the middle term is an even number. But complete the square has its limitations. Take a look at this next problem. I have 3x squared plus 7x minus 2. All right, now let me show you why complete the square has limitations. We know from this point, my first term is not a plain x squared. So in order to work with complete the square, you have to have the first term be a plain x squared. That means you have to divide every single term here by 3. Okay, so we divide by 3 and we get a plain x squared. But look at what happens to our middle term. We now have a fraction. And we have a fraction for our third term. Now, not that the fraction is a bad thing for the third term, because we would move that over to the right side of the equation, but it's this fraction in the middle. We'd have to divide that by 2. Well, 7/3 dividing by 2 is like 7/3 times a half, dividing by a number or timing by its reciprocal, gives us 7/6 that we would have to take, and then now I would square 7/6. So I'd get 49 over 36 that have to be added in on both sides. Well, that's a mess. And mathematicians didn't like it either. So they started working more with quadratic equations to see if there was a better way or a different way to do it. What they found was this, the quadratic formula. So why don't you write this down and label it as the quadratic formula. And let me type a label on there for you. But this is the quadratic formula. It's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Or in other words, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That was to the melody of Pop Goes the Weasel, but that's one way you can remember the quadratic formula. So how do we use this formula? Well, pause the video and write this down, and then I'll show you. Okay, so now that you've got it written down on your paper, I'm going to start to show you how we use the quadratic formula. This is a quadratic equation. Anything that starts x squared like at all, it's 2x squared like this one, or just a plain x squared, those are all considered quadratic equations because they start with an x squared. So how do we deal with this and how do we use it? Okay, in a quadratic formula and in a quadratic equation, the number that's right here, this 2, this is considered a. This 3 is b, and the negative 6, that's c. And what all I do is I substitute into the formula. And once I substitute into the formula, I start calculating. So let me extend my page here a little bit, and I'll show you how we do this. So to start with, I would take my pencil, and I'm just going to write x squared equals the opposite of b. b is positive 3, so I put negative 3. And then I put plus or minus the square root of, and I'm going to write b squared. So that would be 3 squared minus 4. A is 2, so I'm going to go parenthesis 2, parenthesis, times c is minus 6. And then I'm going to put this all over 2, and then a is 2 again, so 2 times 2. Now I've substituted into the formula. Now I get to calculate. The beauty of the quadratic formula is it works with all quadratic equations. And again, it works with all quadratic equations. Complete the square has its advantages, and you'll see when we get into later on, like lesson 8.3 or 8.5 and 8.6, that there are times to use complete the square. The nice thing about quadratic formula is you can use it to solve any quadratic equation. So let me continue to solve here. X equals the opposite of 3 plus or minus, put my square root symbol. That wasn't a very good square root symbol. There we go. 3 squared is 9. And now negative 4 times 2 times negative 6. That's going to be a positive 48. So I'll have plus 48 all over. 2 times 2 is 4. Next, and just keep working here. X equals the opposite of 3, or negative 3, plus or minus the square root of 57, all divided by 4. And at this point in time, I'm going to stop. And the reason I will stop is my radical here, the square root of 57, there are no perfect square factors inside 57 to simplify and remove from the radical. I don't have any common factors in all 3 terms that I can divide out. So at this point, I'm done. Now, how many answers do I have here? I have 2 answers. The first answer is negative 3 plus the square root of 57, all divided by 4. And the second answer is negative 3 minus the square root of 57 divided by 4. So actually you do have 2 answers. That's because of the plus or minus in the middle here. Now, when you do and work with the quadratic formula, you can get answers at the end of it that will say this, that x equals negative 2 plus, whoa, where did that come from? Oops, I need my eraser. All right, here we go. Done making a mess. All right, negative 2 plus or minus 3i. You can have times where you actually will have the imaginary number underneath there. And you might have a different number besides 4, but you could have an answer that looks like this. You could run into imaginary numbers. You could also have times where you're going to be doing your work and you'll see an answer that looks like this, that x equals 5 plus or minus the square root of 0, all divided by 2. Oops, that's a bad 0. There we go. Well, the square root of 0 is 0, so then I would change this to 5 halves. There are times when you calculate with the quadratic formula, you get just a 1 number answer. Like many times you're going to get 2, but once in a while, you're going to get 5 halves. That will happen when you have 0 underneath the square root symbol. All right. Speaking of underneath the square root symbol, let's look back at the formula for a second. What's underneath there? B squared minus 4ac. Well, b squared minus 4ac has a name, so write this down. This is called the discriminant. Okay, and that discriminant is just the part of the formula underneath the square root symbol. So it's b squared minus 4 times a times c. Well, what does this tell us? It actually does tell you some things. All right, if the discriminant happens to be positive, if it's positive, you're going to have 2 real number answers. If it's negative, you're going to have 2 non-real answers. That means I is involved, like I have in the red answer up above. And if it is equal to 0, then you have 1 real number answer. All right, so that is something you can take a look at. If you're working with the discriminant and the part underneath there, it will tell you how many answers you should be getting. Most of the time you're going to have 2. Sometimes you're going to have 1 if it's like this blue example that I have here, that you have 0 underneath your square root symbol. All right, so here's what I want you to start with. I want you to start with this. I want you to go to page 496. 496. And we're going to do numbers 5 through 19 odd, and then 5 more problems, 23, 27, 41. Type, Mr. Ollenberg, type 43 and 47. So again, I'm using odd numbers. Please show your work, show the steps out like I have shown you here, but I'm using odd numbers so you can check your answers in the book and get your feedback. Okay, give that a try. Let me know what I can help you with.